Hello one and all, I hope you're all well. I'm about to present to you a video lesson, and this video lesson is going to be looking at a different type of geographical feature. In fact, it's going to be looking at two different types of geographical feature, and those two features that we're going to be looking at in today's lesson are headlands and bays. So without further ado, I'm just going to present my screen so that you guys can see what we're going to be looking at during today's lesson. So, as I mentioned, today's lesson is all going to be on headlands and bays. So if I present up my screen, you'll see that we've got today's title for the lesson, which is, of course, headlands and bays. We've got 3 pieces of success criteria, which we're going to be guiding our way through. And then we've got a target question, which is linked to this picture that you can just see down here in the bottom right-hand side. So in terms of our success criteria, if I'm giving you a lesson, which is looking at headlands and bays, you need to know what the difference is between the two. So the first thing we need to be able to do is to explain the difference between headlands and bays. Now, as with a lot of things geography, one of the key things that we're going to need to make sure that we can do is to be able to apply keywords as much as we possibly can. Now, headlands and bays are 2 of those keywords, but there are lots of other keywords which we're also going to need to take into consideration. And as with a lot of physical process questions, which is what this question is that you can see on the right-hand side, we need to be able to sequence our answer. Now, remember, sequencing your answer means putting things as a series of different steps. This happens, then this happens, then this happens, then this happens. And ultimately, you're going to know whether you can do that by being able to answer this target question here, which says, explain how features shown in figure 1 are formed. So the first thing that we need to know is we need to know the difference between 2 different types of coastline. And we need to know what the difference is between a concordant and a discordant coastline. And this is where I'm going to start to throw lots of keywords at you. Now, obviously, concordant and discordant are 2 keywords that you need to know, but we also need to know about different types of rock. So before we get to concordant and discordant, I think it's really important that you know the difference between a less resistant rock and a more resistant rock. Now, in the 2 pictures that we can see in front of us, I've given you 2 examples of different rock types. This rock type that you can see here is a cliff which is made up of boulder clay. Now, boulder clay is less resistant, and what that means is it erodes much, much quicker than the more resistant rock that you can see on the right-hand side. And the rock that you can see on the right-hand side here is more resistant. It's chalk, which means that it erodes much slower. And actually, if you look at the pictures, you can probably see that. Here we've got lots of evidence of rotational slumping occurring and mass movement because that boulder clay is really, really vulnerable to processes from the sea, but also subaerial processes such as the rain coming from above. Now, if we look at these 2 different types of coastline, they're obviously going to erode at different rates. The boulder clay, which is the less resistant coastline, is going to retreat and erode much quicker, whereas the chalk, which is more resistant, is going to erode much slower. So that brings us to our key words, concordant and discordant coastlines. Now, this little diagram that you can see here shows us a small area of the coastline down in Dorset around an area called Swanage Bay. Now, what we can see here is evidence of those concordant and discordant coastlines. So down here towards the south, we've got a concordant coastline. And if we look at the key, we can see that all of the rock that's made up on this part of the coast is all limestone. And limestone is a hard or a more resistant rock. So what that means is on this concordant coastline, this rock will erode at a similar rate because it's a similar rock type or the same rock type. I always used to be able to remember that, and it's a bit of a strange way of remembering it, as the planes called Concords used to fly in a straight line to get to their destinations quickly. And this is a concordant coastline because, by and large, it runs relatively in a straight line because the rocks are eroding backwards at the same pace. We then get to a discordant coastline, and a discordant coastline occurs when we get bands of harder rock and softer rock. So if we have a look here, we can see that we've got the limestone on this part of the coastline, followed by clay and sand, which is less resistant rock, followed by chalk. So what we've got here are different bands of rock. So the discordant coastline occurs where we've got different bands of rock, some of which is hard rock and some of which is soft rock. Now, because of that, we get what we call a differential or a different rate of erosion. So that hard rock that you can see here is eroding much slower than the soft rock that we've got forming around this area where you can see Swanage Bay. And that brings us to our features that we're looking at in this lesson, which is the formation of headlands and bays. Now, before we can talk about the formations of headlands and bays, we've got to be 100% clear on what we mean by a concordant coastline, where all of the rock type is the same, and a discordant coastline, where you get alternating bands of hard and soft rock. So let's have a look at my definitions. My definitions look like this. I've said that a concordant coastline is made up of the same rock type, and this usually means that the coastline erodes at a similar rate. So again, we're looking at this band of hard rock that you can see down here of limestone towards the south of this piece of coastline in Dorset. Whereas a discordant coastline is made up of a mixture of more and less resistant rocks. And this means that the rock types will erode at a different pace, with the less resistant or the soft rock eroding much quicker. Now, I've put a timer into my slide deck today. So what I'm going to do is I'm going to push play on that timer, which is going to give you 3 minutes to either use the information that's in this video or to use your own words to give me a definition of a concordant and a discordant coastline. Away we go. Okay, and hopefully that's given you enough time to get that information down. So just to reiterate, the concordant coastline is a coastline which is made up of the same rock type, so it erodes at a similar rate, and the discordant coastline has alternate bands of hard and soft rock, causing a differential or a different rate of erosion. So that leads us to the formation of two features. So we've got headlands and we've got bays. Now, I mentioned an example earlier, which was the area around Swanage, and here you can see a lovely picture of Swanage Bay. This area that my mouse cursor is in at the moment represents the formation of the bay, whereas this bit that you can see of hard rock sticking out here is our headland, okay? And in our next lesson, what we'll do is we'll look at how those headlands erode in a series of sequence steps. But before we get there, we need to be able to say how our bay forms, where you can see these lovely people enjoying the sunshine on the beach, and how our headland is left sticking and jutting out to sea. So in order for us to be able to do that, what we need to do is to look at a diagram. And what we've got here is a nice sequence diagram. So we're looking at the coastline from above as if we were a bird flying over it. And we can see that in picture A, we've got a discordant set of coastline. So we've got alternate bands of softer, less resistant clay, more resistant sandstone, less resistant clay, and then again, more resistant chalk or limestone. And what that means is that we're going to get different rates of erosion along our coastline. So it goes without saying that our less resistant rock or our clay is going to erode much quicker than our more resistant rock, which is our sandstone and our limestone or chalk, which you can see down here. Now, if we look at sequence diagram B, we can see that the less resistant rock has been worn away. And what that does is that forms this nice little indent in the coastline, which we call a bay. Whereas the harder rock has been left jutting out or sticking out to sea, which forms this feature which my cursor is just circling at the moment, which is our headlands. Now, where we get a bay, because it's much more sheltered, the power of the waves is much less, so they've got less energy. And what that does is it encourages deposition. So we tend to get sand building up on the insides of bays. And actually, if we go back to our image of Swanage Bay, which you can see here, you can see that that deposition has formed this nice little tourist attraction that we've got down here, which is the beach at Swanage. Now, in addition to that, we've got another headland which is sticking out on the other side of the bay, okay? And that's because it's, again, that harder, more resistant rock that erodes much slower. So again, if we go back to our nice little picture of Swanage, you can see that this is the more resistant chalk or limestone. I can see that because it's white in terms of its color. And then the less resistant rock, which is the clay, has been eroded here to form the bay. And actually, if you look really carefully at this part of the cliff, you can see that it's a different color. It's a browny color, which is the color of the clay, which shows us where the areas are of less resistant rock, where that erosion is happening the most. So that's our process in a series of sequence steps. Now, I wanted you to be able to answer the following target question. And it says, explain how the features shown in figure 1 are formed. And you can see that we've got here the headland and that we've got the bay. Now, in order for you to be successful in answering this question, there are 4 things that you need to do. You need to identify, firstly, what you can see in the video. Okay, now I've given you a big helping hand here, not the video, sorry, the picture. I've given you a big helping hand here because I've picked out that this bit here is the headland and this part here is the bay. You need to be able to sequence your answer in a series of steps. Step 1, this happens. Step 2, this happens. Step 3, that happens. And you want to showcase your geographical knowledge. So you need to use as many keywords as possible. Concordant, discordant, more resistant, less resistant, erosion, okay? Maybe even throw in some types of erosion, talk about hydraulic action, abrasion, if you really want to take it a bit further. And geography, I say it time and time again, is a study of the real world. So because it's the study of the real world, it's always good to be able to give real world examples. So if I look at the question, my command word is explain. That tells me that I need to be able to give reasons, which comes into that sequence of steps. It asks me to explain how the features, which is what I would underline, our headlands and our bay, are formed within figure 1. So I've got to make explicit reference to figure 1 within my answer. So you'll notice that there's a timer down here in the bottom left-hand side. What I'm going to ask you guys to do now is exactly the same as you did before. I'm going to ask you to go back and I'm going to ask you to have a go at the question. Not only am I going to ask you to have a go at the question, but I've put a 6-minute timer on the screen up here, and I'd like you to do it within that 6-minute time limit. Once that timer is ticked down to 0 after those 6 minutes, we'll have a look at my model answer to the question, and we'll guide you through my model answer and the success criteria for your final task of today's lesson. Okay, 6 minutes, guys. The clock is ticking. Off you go. Okay, just to give you a time check, there's 2 minutes left. If you've already answered your question, rather than fast forwarding the video, have a read back through your answer and have a look at the criteria of those 4 steps on the left-hand side. See if your answer has hit those 4 steps on the criteria. Okay, final 30 seconds. Okay, and time up. Apologies if you heard my daughter crying a little bit in the background there. I guess that's what happens when you start making videos during this time of lockdown. Okay, right. So hopefully you've had an opportunity then to answer the question. What I would like us to do now is I would like us to have a little look through my model answer to the question. So I'm going to start off by reading it to you. It says, in figure 1, I can see a headland and a bay. These features are formed on discordant coastlines. This means that there are bands of rock that are of different resistance. For example, sandstone and clay. The resistant rock erodes quicker than the less resistant rock erodes quicker than the more resistant rock. This leads to the formation of bays. Deposition will occur in the bay where the wave energy is lower, forming beaches. Where the more resistant rock is eroded much slower or erodes much slower than the less resistant rock, a headland is left sticking out to sea. An example includes Swanage Bay in Dorset. Now, your answer might look similar, okay? Your answer may look slightly different from mine, but I wanted to show you my answer so that you can see how I'm going through the success criteria and so that you can see the sophistication of language. So let's have a look at how I've started my answer. I've said in figure 1, I can see a headland and a bay. So the first thing that I've done is I've identified exactly what I can see in the figure and I've mentioned it. Second thing that I've highlighted here is where I've sequenced it in a series of steps. So I've used phrases like this leads to be able to explain the different steps. So my first step is the less resistant rock erodes quicker than the more resistant rock. My second step says this leads to the formation of bays and headlands. My next step is deposition will occur in the bay because the energy is lower. Then my final step is where the more resistant rock erodes. Now, there are loads of keywords that I've used in this answer, and I've highlighted them in green on the screen in front of you. You've got discordant, you've got resistant, sandstone, clay, less resistant, bays, deposition, and headlands, okay? Just a whole multitude of different keywords that I can use to show off to an examiner in the GCSE exam just how much I know and how much I understand. And then finally, point 4 is to be able to give a real world example. And the real world example that I've given is from that wonderful picture that I just showed you of Swanage Bay. So this is what I wanted you to learn from this lesson. I wanted you to learn differences between headlands and bays. I wanted you to be able to use keywords, concordant, discordant, more resistant, less resistant, different types of rock, sandstone, chalk, clay, to be able to explain how they're formed. And hopefully you can sequence your answer by answering this target question, which I've got up here, okay? If you wanted to, you could have a look at my model answer and perhaps pause it on this final screen and perhaps maybe see how you can change the original answer that you've just written to try and improve it based on my 4 steps and based on my model answer to the question. I always say using model answers is key because unless you know what success looks like with a question, How do you know what it is that you're aiming for? If you've got any questions, please feel free to comment, send me an email, use Google Classrooms in the same way that we normally would. Hopefully this lesson has given you the information that you need in order to be able to explain the formation of headlands and bays.